we're going to go through some more not so simple harmonic motion problems. In this problem, Mark Twain is sitting on the deck of a river steamboat. As the paddle wheel turns, a point on the paddle blade moves in such a way that its distance, d, from the water's surface is a sinusoidal function of time, sine or cosine. So from this, we already know that our x value is going to be time and our y value is going to be distance. The information that the problem gives us is that when his stopwatch reads 4 seconds, the point is at its highest, which is 16 feet above the water's surface. The wheel's diameter is 18 feet and it completes a revolution every 10 seconds. So we know that time is measured in seconds and that the distance above the water is measured in feet. So we know that the highest point is 16 feet. What we don't know is what the lowest point is, but this problem gives you another piece of information, which is that the diameter is 18 feet. So if this is my wheel, and I know that the diameter, so from here to here, is 18 feet, I can actually figure out what my lowest point is going to be by doing 16 minus 18. So 16 minus 18 gives me -2, which tells me that my lowest point is going to be -2, which is 2 feet below the water surface. So we know that at 4 seconds, the point is at its highest, which means up here. And then it's going to go all the way down to -2 and then back up to 16. This is a full cycle. And we also know that it completes a revolution every 10 seconds. So if it completes a full revolution every 10 seconds, this is its period. So its period is 10 seconds. To write my equation, so A, the amplitude is max minus min over 2. So 16 minus -2 divided by 2 is 18 over 2, which is 9. My B value is 2 pi divided by the period, which is 10. And we could actually simplify that to pi over 5. And then K, which is the maximum, which is 16, minus the amplitude, which is 9, gives us 7. So now using all this, I can write my equation for this function. So if I start at this point right here, I know it's starting at the top, so this is going to be a positive cosine function. So 9 cosine 2 pi, actually just pi over 5, because we simplified it. X minus, in this case, we're using this point, so it's moved to the right 4. So it's x minus 4, close parentheses. And then we're adding our k value, which is 7. So this is my equation that I'm now going to put into my calculator. So in y equals, I have 9 cosine pi over 5, x minus 4, close the parentheses twice, and then add 7. And now we're going to go ahead and change our window. So our x is going to start at 0. Let's have it end out. We want it to be something larger than 4 and probably way out here. So if we did 4 plus 10, this is actually going to give us 14. So let me just end it at 14. For my y, I want it to go below -2, so let's say -5, and above 16, so let's say 20. And then graph it. So to check to make sure my graph is correct, I'm going to make sure that this point is a part of my graph. So I'm going to press trace, x equals 4, and that should give me 16, which it does. So this looks like it is correct. From here to here looks just like this one. I could also type in 14 and make sure that also gives me a 16, and it does. Okay, so using this, let's answer some questions. How far above the surface was the point when Mark's stopwatch reads 5 seconds? So seconds tells you this is your x value. So we're just going to go to trace 5, enter. And it gives you a value of 14.281. Because this is your y value, this is going to be feet. For 17, when I press trace x equals 17, it's an error, which again tells us our window is not big enough. So let's go back to window. Let's change our x max to 20, just so the 17 can be included. And then once this graph, so we're again going to press trace. And 17. And that gives you a y value of 4.21. Let's round this up to a 9. Again, feet. Okay. So the next question is asking you, what is the first positive value of time at which the point was at the water surface? So if you are exactly at the water surface, this is when your height is going to be 0 feet, because you're 0 feet above the water, because you're exactly at the surface. So our y value is 0. So that's what I'm going to put into my y2. And I'm going to graph this, and it's going to graph a line right at the 0. I want the very first time that this graph intersects this line. So I'm looking at, if you look really closely, you can tell the first time it intersects is actually going to be right here, very, very, very close to the y-axis. So I'm going to go second trace, intersect, and then move my cursor all the way over here to this very first intersection point, which again is kind of hard to see, but it's right on the edge. So then enter, enter, enter. It gives you an intersection of 0.082. Again, we're rounding. And because this is your x value, this is time, which is in seconds. Part D is asking us, at this time, is your Ferris wheel, or your steamboat, excuse me, going into or coming out of the water? So, looking at your graph, at this point where it intersects 0, is it going into the water or coming out of the water? So the 0 represents the water. So at this point, it's increasing, because it's going up. So that means it is coming out of the water. Because the function is increasing. Okay. Finally, our last question is asking us, how long will it be at least 10 feet above the ground? So again, 10 feet is your y. So we're going to go to y equals, type in 10, and graph it. And this question is a little bit different than the ones we've done before, because it's asking us for how long will we be at least 10 feet. So at least means above, greater than or above. So we're looking at how long is this graph right here going to be above this line. So just like yesterday, we're going to be looking at for 2 intersection points. So second trace, intersect. Let's first get this first one right here. And you should get an intersection point of 2.041. And then do the same thing for the second one. .959. So here are the 2 intersection points that you should get. This problem is different because it's asking us how long will it take between these 2. So now that we have these 2, we're actually going to subtract 5.959 minus 2.041, and that's going to tell you how long it is above 10 feet. So 5.959 minus 2.041 gives us a value of 3.918. And because these were your x values, you are going to be above 10 feet for 3.918 seconds.